In this video, we're going to take a closer look at platform models, as well as signature models and icon models. It's important to watch these videos in the order that they're specified on the website, so you should have just watched the video for how to employ a platform model on a unit. So I'm right where I left off in the previous video. I've got my composition tutorial units in my composition tutorial scenario, and I've got one unit with a single statement called named employee platform, and my unit composition now lists that platform object as the composition of the unit. So now we're going to start talking about platform models. For units, you can attach any number of each type of model. So you can have any number of cognition models or sensor models or data processor models, whatever. The exception is platform model. You can only attach one platform model to a unit. So it's a special model in that sense. And it should make sense. The platform model is really the vehicle of the unit. So it wouldn't make sense for a single unit to actually have multiple vehicles associated with it. So you can only have one platform model. And as I just said, the platform model is the vehicle of the unit. So as the vehicle, its primary role is to move the unit. So that's the primary thing that platform models do. They also are intended to provide the observable characteristics of the unit. So it's the platform model that you're looking at when you have a sensor. The platform will, for example, will have a radar cross-section. So if you're trying to detect another unit with a radar, you'll be looking at the radar cross-section of the platform, of the vehicle. And the same is true in electro-optical or infrared. It's the platform gives the unit its primary observable characteristics. So that's another real important role of a platform. If you have a unit in a scenario that doesn't have a platform, and that's possible, you can have, for example, multiple units that are the individual humans that are all within a single vehicle. So only one of those units would have a platform, and all the other units would not have a platform. But we don't usually model it that way. Usually, we model all the humans in a vehicle as a part of that one unit. But you can do it any way you want. But if you have a unit in a scenario that doesn't have a platform, it's not going to be able to move independently, and it's not going to be able to be detected independently by most sensor models. Now, of course, you can write a sensor model that uses any criteria that it wants to be able to detect, but normally sensor models are looking at the platform. So if a unit doesn't have a platform, it can't be detected. Having a platform alone does not actually allow the unit to move. It gives it the ability to move, but you have to have a cognition model. You have to have a human that's driving the platform in order to actually locate the platform and actually cause the platform to move. So we're not actually going to be able to see this platform on our map, even though it has everything that it needs to be able to be drawn on the map. Because I can't locate it, I can't place it on my map in a place where I can see it. But we'll get to that in a following video when we look at cognition models. So for now, we're going to dig in a little bit more to the platform model. So we talked in the previous video about the parameters that are common to all platform models. So we're going to dig into those a little bit more deeply here. The first is team. So every platform model has a team associated with it. And this team is specified at the platform level. So when you attach a platform to a unit, you automatically specify the team to which that unit belongs. So I'm going to go take a quick look at teams. You can specify the team just by picking a list of teams, picking from a list of teams. These are the teams that are loaded in the scenario. And I can go look at the definition of that team by looking at this button. And you've probably already figured this out. I think we've already talked about it, but whenever you see button like this. This is a button that lets you browse for a name that would be a legitimate input for the field that you're trying to edit. And then this lets you go and look at the object that is referenced in the field. So in this case, I could browse for a name of a team, and here I can go look at a team. So I'm going to go click on this, and it's going to open up the Teams window. And this window is the same window that you'd get. I'm going to close it now and go look at the parameters environment, and I'm going to look at Teams here. So it's the same window. Teams cannot be customized. These are built into Flames. You don't have to write any code for these. It's a built-in type of object in Flames. There are two classes of team. One of them is just a team itself that is intended to specify the individual team of a unit. And then another one is an alliance. So the team is very simple. All it does is just specify a name and a color. And that's it. This is an extra attribute that is specified if you're going to be using Flames in a DIS scenario. So this specifies a parameter that's necessary when you send out DIS entity state PDUs. If you're not using DIS, you can just ignore this. So really all team is it's just a name and a color. That's it. By default, teams do not have any relationship with other teams. They're not friendly, they're not hostile, they're not an ally, they're not an enemy. The team itself does not specify that. That gets specified in alliance objects. So you've got two different types of two different classes of team type classes here. The other one is alliance. So let's go look at an alliance. Alliance specifies a list of teams that are allies and a list of the teams that are enemies of this alliance. So in this case, I said, well, this thing called the Blue Alliance has the blue team on it, and the enemies of the Blue Alliance are any units that are members of these teams. So you can specify any number of alliances that you want, and you can specify that the relationships among the teams does not need to be symmetrical. So I might say that the red team is my enemy, but if I went to a red alliance, and so that's what I'm on right now, it may have different teams that are enemies, or may not have the blue team as an enemy. So the alliances can be asymmetrical, the relationships among the teams. So again, the team itself is just a color. It's just an arbitrary name. It's the alliance that specifies the relationship. In Flames, you have a way of going to two units and saying, are you allies or are you enemies? And Flames will just go and look at the two units, and it'll look the team affiliation, it'll look at all the alliances, and it'll come back and tell you whether they're enemies or allies. If a unit is a member of a team and that team is not part of any alliance, then all the other teams, well, it depends. If it's not part of any alliances, which means it's not mentioned in any enemies or anything, then the relationship would be unknown. So we wouldn't know how these two teams are related. Now, again, this is the true relationship between the teams. It's up to the models, the cognition models, to determine whether they really know that true affiliation, that true relationship. You can choose to go to the truth and look at that, or you can say, well, I'm not going to know what its relationship is unless I look at some other attributes, or unless I get some intel, or unless I get somebody that tells me more. I look at the type of airplane or something like that. So again, this is all defined by Flames, but in terms of the classes, but you get a chance to edit it any way you want. And most Flames scenarios will have at least one team data set. And you'll notice that we could have we could have NATO and all different kinds of relationships here, different kinds of alliances. So I'm going to close this off. So I specify the team here, and when I attach this platform to a unit, it specifies the team of the unit, and automatically then all the alliances and enemies, allies and enemies that unit has. Next is the icon. So this is the data that is used to draw the unit in the 2D view. And as I've already mentioned, I'm not going to be able to draw it because I can't locate it. But icons can be, in general, cannot be edited in Forge. So I'm going to go browse to this. So this is the icon window. The icons cannot be edited in Forge. They get edited in the Flames 2D icon editor. So that's something that you get when you get a paid version of the Flames developer. You can edit these 2D icons. Not Flames developer, I'm sorry, the Flames engine. So there's another tool that you can use to specify, to create all these images for the 2D icons. And the icons can have articulated parts and animations as well. So this particular icon has the 2D icon has a turret that moves. This helicopter, the blades will rotate on that, and you've already seen that probably in Flame Scenario. So icon editing is not part of this series of videos. It's a whole nother application that we use to edit 2D icons. The same is true for 3D icons. This is how the unit is drawn in the Flames 3D view. So I can go look at that, and it's the same icon editor, and I can and it shows me the view of this. So as I click here, I can just see things, and this is how the unit will be drawn in the 3D view. So we'll look more about drawing in another video. So I can specify how the unit's drawn in 2D and 3D, and that's just associated with the platform. It's the vehicle. And then I get to specify signatures. So this blue light truck, it doesn't have any signatures associated with, but the red truck does. And again, it's up to the sensor model, but generally a flame sensor model doesn't look directly at the platform in order to detect it. It looks at the signature of the platform. And a platform can have multiple signatures associated with it. So it could have an infrared signature, it could have electro-optical signature, it could have an acoustic signature, it could have radar signatures in different frequency bands, millimeter wave, and a lot of different types of signatures, which is why the signatures are separate objects. If I click on this button right here, I get the signature selector, because specifying a signature for a platform is a little bit more complicated. It'll show you all the different loaded signatures here, and we only have one in this very simple scenario. And then you can add each one here to the list of signatures that are attached to this particular platform. Signatures themselves are edited in they're attributes. In fact, icons are attributes as well as signatures. So these are all subclasses of attribute. And in general, an attribute is an object that specifies additional input parameters for another object. So you don't attach attribute models directly to a unit. Attribute models are attached to other models. And again, it's a way of specifying additional input values. The reason we specify those values separately is because we don't want to make the user interface for the object, like the platform object, have all the inputs that are necessary. It would make the user interface very complicated. For example, if you had to specify all the values for all the signatures on the platform window itself, it would make the user interface for the platform model too complicated. So by putting in an attribute model, we can specify the inputs in a separate window. So that's one of the reasons why we use attributes. The other reason, though, is illustrated by this signature thing. We may want to attach multiple instances of a given type of attribute to a model. So we can have any number of signature models attached to a platform, which is why we implement the signature as a separate object. We also want to be able to swap it out. So a given platform object, we could create another copy of it and use a different icon or use different signatures. So by making the attributes separate from the platform, it allows us to swap different attributes out and not have to have, and even different classes of attributes, and not have to have different classes of the platform class. So that's just a little bit of an introduction to attributes and why it is that we specify some things as attributes. The signature window looks like any other entity class, and we only have a very simple signature here, and all it does is have a constant radar cross-section value. And we use this just to illustrate how radars work in Flames. It's very simple. The starter model, signature models, are much more complicated than this. They have main beam and side lobe and back lobe, and there's a skirt for the lobes that follows a cosecant profile, and it gets really complicated. But we don't put all that complexity because we're just trying to teach the basics here. So again, getting back to the main point, in order to have a platform model that can be detected by a sensor, most sensors will look at the signatures attached to the platform, not the platform directly. So if you don't have a signature of the right type, the right frequency band, the right type of sensor attached to the unit, a particular sensor won't be able to detect the unit. It won't be able to detect the platform. So signatures are very important. You can write sensor models that don't pay attention to signature, but and that's up to you. But in these tutorial models, we show you how to use signatures. So I'm going to close this window so you attach the signatures to the platform model. So when I attach a unit, when I employ this blue light truck, it doesn't have any signature. When I attach any platform model, I get a unique instance of the icons, and I get the name. So all I have to do is say the name of the team, and I get a unique instance of all the signatures. And all those things all get cloned, and they're all attached to and hung off of this platform model that's attached to the unit. So this platform models are generally composite models. They're actually a collection of models at almost always icons, 2D and 3D icons, but in addition, they'll oftentimes have signatures attached to them. So you get all of that, all of those things all get cloned when I use this employ platform statement. So we'll learn a little bit more about how platforms work after we get a chance to talk about cognition models, because again, platform models can't move and can't even be located unless there's a human that's controlling the platform. So we'll come back to talking more about platform models in a successive video after we talk about cognition models. So that's all I want to say at this point about platform models. They are extremely important. And again, you can only have one on a unit, and almost every unit will have a platform model. Thank you for watching, and thank you for using Flames.